extreme, oops, without split the data, isn't it, guys? Without split the data, because we have very less records. We have very less records. Is that working? Is working? Is working? Okay. So it's working, but no air, right? Yeah. So we build this model without split data because we have very less records. And we build polynomial model. And in polynomial model, we change the degrees as well. What are the degrees, guys? By default in parameter, what is the degree? Parameter tuning by default second degree. And in hyperparameter tuning, how much we have? 3, 4, 5. And we keep increase. Maximum we do checked it. We do checked it. And also we compare the model predictions salary for, okay, as per the degrees we changed. As per the degree we changed. So team, understand this one? Okay. So COMPARE. So we done the again. Let's copy and we done this now. 49. Let me finish all machine learning regressions. I'll take up a test. Okay, for regressions. I'll take up a test for machine learning regressions. Okay, minimize and open. Always remember, whether you work on regression or classifications, the data set is one itself, isn't it? I mean, so let's say you're working for a banking domain. In the bank domain, we have a data set or not? I mean, some of the customers financial transactions and customer salary, and we have all these records. So we can make a data set of the customers. Let me tell you, any data set you worked, you must need to build multiple model on same data set, guys. You understand? I mean to say, yesterday we have a data set. Which model we built? Polynomial model. And what is model predicts for 6.5 level experience? What is the model predictions, guys? 174 point, I think 7, 8 something, the model predicted, isn't it? Let's pass same data set to SVR algorithm and KNN algorithms, guys. Can we go ahead and understand? But before we pass to SVR, we must need to know what is meant by support vector regression concepts. Let's discuss and then we build the model, guys. Let's discuss this and then we build the model. Online team, are you guys joined, everyone? Okay. Yes, let's start now. Okay. See, in the world, the domains are different. What are the domains? I mean to say, sir, if a problem statement given, how can we know whether it's multilinear or polynomial? We know one data sets, you build all the models, guys. Understand? And the model which has best accuracy, that one we go for a deployment. That's what, see, I'll explain one by one and then we combine all the model, we build a practical. Using Pickle, we have a lot of files, a lot of practicals we have. Just understand concepts and practical, we finish this regressions concepts. Clear? So till the time, just be patient. Domains are different. How many domains we have? BFSI. What is BFSI? Banking, finance, service, insurance. Attributes are different based on a business or not? Banking, we have banking attributes. Finance, finance attributes. Attribute means column names. Service sectors, column names are different. But what cannot change is algorithms never changed. I hope understand, guys. Domains are different, but algorithms are never changed. So today I introduce a concepts called SVR. So just go ahead and let's finish this SVR. Okay. Also, I'll mention all regressions model. I'll explain 30 to 40%, and at classifications, I'll explain rest of the things, guys. In classifications model, I'll explain rest of the 60%. I mean to say all these algorithms I'll explain two times, SVR and SVM. SVR refers for regression. SVM refers for classifications. Decision tree refers for regressions and decision tree for classifier. So if all these algorithms will understand two times, guys. Okay. Have a look at this and try to understand. Let's assume I have a graph, x-axis and y-axis. Clear? Assume I have some of the data points over here, and over here some of the data points. The data points scattered. The data points are scattered. When the data points scattered, that means regression or classification. Regression. 0 and 1. That means this is a classifications. Now let's see. I'll draw a line, isn't it? So this line separate the two data points or not? Okay, guys. Now let me move this to here, or maybe the best way I can plot in one note. Let's understand this. Close. Draw. Have a look at this. So this would be, I can little bit bigger. This would be X and this would be Y. Assume I have some data points over here. Okay. And somewhere the data points I plot here, guys. Now, if I plot a best fit line, what is equation of this line, guys? Y equal to mx plus c, or I can write y equal to wx plus b. Okay, multiple. Let's see. This is my question. From this side, this point is closer. In simple linear regression, we called as best fit line. We call this concept as, in SVR, we call this as hyperplane. So interview, what is difference between simple linear versus support vector? In support vector, what concepts we call, guys? Hyperplane. But in simple linear regressions, we called as best fit line. From this side, this point is close to this line or not? This point is close to this line, guys. So let me plot a parallel line to my hyperplane. Getting my point? And from this side, do you know, in school days, we understand this side is positive points and this side is negative point, isn't it? The one side of the line is positive, another side of the line is negative. So in this side, let's see, this is closer. So I plot a parallel line to this one. So here, this is called hyperplane. This line we called decision boundary or support vector line. This also called as support vector line or decision boundary. Are you guys understand? Are you guys understand or not? So here in today, I introduced to hyperplane, decision boundary, and support vector or decision boundary, anything we call this, guys. Now let me tell you, if this side data points. I just plot a line here. In simple linear, we call it as best fit line. In support vector, we call this line as hyperplane. Clear? And from this line, this is the data point is closer to the hyperplane or not. So if I plot a parallel line, this is called decision boundary or the support vector line. If I plot a parallel line to this, this is called my another decision boundary or support vector line. Understand up to this offline team? Now, if this distance is positive, can I say Wx plus B is equal to positive A or not? That means all the distances are positive, guys. So my equation is Wx plus B is equals to positive A. If this distance are positive or negative? Negative. So what would be my equation? Wx plus B equal to negative A. So can I say, can I fit this equation like this, guys? I mean to say, have a look at this. This is decision boundary. Now, this is the hyperplane, and hyperplane, we plot the two parallel line. This is decision boundary or support vector line. Now go ahead and understand. In this case, Wx plus B equal to positive A. Are you guys understand why we got positive A? Because one side of the plane is positive and other side of the plane is negative. So can I fit my equation like this? Yes or no? Minus A is less than Y Wx plus B is positive A. Yes or no? That means the support, that means the hyperplane. Okay, again, this, anyone has mouse, guys? Give me that. So this line is fall under these two lines or not, guys? So, team, are you getting my point? So here, this would be minus A is less than Wx plus B is less than positive A. Give me, where is the, huh? Can you remove that? 1 second. One moment, guys. It's not working. Cell is not here. Fix it. एक बार इसको 1 second team. ओपन करो इसको. Sometimes it's working or not. Okay. Let's keep it here and let me check. All right, guys, let me tell you once again. I don't know how many of them clear. This is very simple example. I'll try to explain one more time. Just have a look at this and close it and then go back to the practical. Clear? So very simple. I have a two graph, x-axis and y-axis. Is working now? Cell replace करना पड़ेगा. ठीक है, देखेंगे बाद में. Anyone has mouse? Okay, strange. Okay, leave it. Now let's do this. I have, but how do you pass from there to here, Bhupinder? Actually, today the system, my system mouse had some issue. Okay. So YXB is a hyperplane. Is that? Yes. Okay. Let me explain one more time. Listen to me. In SVR, what is the first concepts we covered? Hyperplane. Guys, are you listening to the class? What is the first concepts, guys? Hyperplane. In SVR, we concepts called as hyperplane. What is equation? Y equal to Wx plus B. Clear this one? Okay, done. And in simple linear regressions, what we call best fit line. So the equation is y equal to mx plus c. mx plus c. So here, if you refer to this, Now I have few data points over here and I have few data points over here. So this is my hyperplane and this point is closer to the line. Let's plot a parallel line. This is called my support vector line or decision boundary. Understand? And this point is close to this line, and let's plot a parallel line. This is called another support vector line and decision boundary. Understand, team? So this equation is YWX plus B, and this side is positive. So I can write the equation WX plus B equal to positive because each and every points are from positive distance. And this one, positive or negative distance, guys? Positive or negative? This is negative distance. So that's why I can write Wx plus B equal to minus A. Hence, I can find out the final equation. Minus A is less than Ywx plus B is plus A. Understand or not? Clear? Second time I explain this. So here, the distance between, okay, I'll close it. And this is positive point. I mean to say Wx plus B equal to positive A, Wx plus B equal to negative A. This is my, again, mouse tucks. So this is called hyperplane, guys. This is called hyperplane. Understand? So here, from the hyperplane to decision boundary, is this positive distance or negative distance? Positive distance. So from this hyperplane to this one, is it positive distance or negative distance? Negative distance. Then my question, the distance between two support vector line is called marginal distance. Is called marginal distance. So in today, the two distance between two SVR is called marginal distance. So there's a few technical points, technical jargons I mentioned here. Just go here and the first one, SVR. Okay, today I don't know. The mouse is not working. That's fine. Strange men offline team, nobody use mouse. Okay, let's do this now. So here, what are the concepts we learn? Hyperplane, decision boundary, or support vector. Clear? And then positive distance and negative distance. And then marginal distance. What is marginal distance, guys? The distance between two support vector is called marginal distance. Guys, are we clear? So concepts clear? Now let me tell you, the marginal distance always maximum. This is what interview question. The interview question, what happened, guys? We have to give it with a, hey, Indra, this one also without cell. If you guys give without cell, how do I access? Okay, you want me to change it? I think 1 second, online team, just 1 moment. ఈ బ్యాటరీ అయిపోయిందనేసి అడిగానబ్బా, మళ్ళీ ఈ బ్యాటరీ ఇంకో దాంట్లో పెట్టాలి. Just 1 second, team. It's working. Let's try. Just 1 second. I'm sorry. Okay. क्या ये काम नहीं कर रहा है नवीन? I think the battery is finished. अब्बा, AC remote also not work. Wait, did you see the brain? Yeah, great. Okay, let's try. It's working. So guys, understand what is always understand the marginal distance should be maximum. The question is why. So I will explain these things in. So understand this little math. Are you clear? So what are the topic we understood? Today we learn what is hyperplane, what is decision boundary or support vector line, positive distance from hyperplane to support vector line, and distance between two support vector line is called marginal distance, and the marginal distance is always maximum. Okay, I'll give you one example and let me know. Assume I always give this example to my student. Let's say this is NH road. In National Highway Road, the distance is maximum or minimum? Maximum or minimum? Online team. It's a maximum. Why? Why? Okay, let's say this is NH road. Assume there's a heavy vehicle truck going by this way. Okay, there is no space other vehicle can go, isn't it? So how this vehicle go? This vehicle will come here and go and pass like this or not? That means, is this error or not error, guys? In this side, these points are error, guys. So let me tell you, if the marginal distance is maximum, it's easy to adjust the error. When we adjust the error, the accuracy is increase or not increase? How many of them understand, guys, what I'm saying? If the maximum marginal distance, then it is a very high time to adjust the error. If you have minimum marginal distance, do you think you can adjust the error, guys? No, when you have maximum marginal, we get more accuracy. Understand, Bhupinder? Yes, guys, online team, everyone. So there is a reason why we need to do a maximum marginal distance, because the moment when the distance should be maximum, we adjust the error more. When you adjust the error more, we get good accuracy or not? We get a good accuracies, guys. Anyway, I will explain more concepts, another a math concepts available for SVM. I will explain with math why these the distance always maximum. Okay. Now very simple, how to compute a distance, guys? Let's say, okay, how the equations generate. Let's see. Okay. So this is, we have a line, guys. This is a positive line, and the distance between two support vector is called marginal distance or not? So what is this equation of marginal distance? Wx plus b is equals to minus a, and oops, just 1 second. 1 second. Now, so try this. So we have, what is equation of this line? Let's assume Wx plus b equal to minus a, Wx plus b equal to positive a. If I ask you questions, what is distance? What is the formula of distance between two lines? Anyone? A minus b or not? So this is a and this is, no, you won't follow. I have a line A, I have a line B. When I do A minus B, can I find the distance between two lines or not? So I mean to say Wx plus b equal to minus a, Wx plus b equal to plus a. If I do a minus, then can I get some values now? So these calculations I'll explain at classifications model, which is SVM. So till today, I hope you guys, okay, ending point minus starting point. No, you can't say that, but you have a minus b. All right. Now, what I'm going to do, let's open a laptop, guys, everyone. And so here, so what are the concepts we covered today? SVR, decision boundary, understand, and then hyperplane we learned, and why we got this equation of hyperplane, and wx plus b equal to plus a, wx plus b equal to minus a. So the hyperplane fit into minus a to plus a, and the distance between two support vector line is called marginal distance. The marginal distance always, it should be maximum. Understand that point. So for the points we understand in classifications part. Okay, team? Good. Let's go back. And now let's open the spider model, which just go ahead to the spider model or not. Now I don't want you to, which is polynomial. No, class practice. Is this fit and transformers? Let me open this model one more time. No. Okay, not this. Can you go and check? Can you open SKLN documentations? In SKLN documentations, which library we will used for support vector regressions? Anyone? Can you go and check a little? You know where to find out SKLN documentations, guys? Do you know or you don't know? Okay, just one moment. I'll show you. Exactly. Okay, I will check the file location. Now, whatever the model we built yesterday, please open that, guys. And what was the degree poorly we fitted, finalized? 5th degree, right? Yes, 5th degree. Just go here and let me restart my kernel. And we run all the code once again. Just wait. Allow. In the same code, you guys done that or not? In the same code, I will fit my SVR model. I'll fit SVR model. So how do I fit SVR model? Okay, so just go to the code and let me close this. So here, I'll create a new line here. I'll create a new line here from sklearn dot SVM, okay, import SVC or SVR, which one? SVC or SVR, which one, guys? SVC for classifier, SVR for, let's go ahead and SVR. Guys, are you clear? Now, in SVR, just go ahead and can you read the documentations? And in the documentations, what is the first parameters we have? I will tell you in classifications what is meant by kernel, LSVM, nonlinear SVM. At this moment, kernel. So do you see, yesterday I was explained what is meant by parameter, hyperparameter, fine tune, all those things I discussed yesterday. Okay, all those things we discussed yesterday. Now what we try to do, just go here and, okay, just one second. What happened? This one is not working. Yeah, just apply. But before I will remove this one, and can you tell me, kernel is one parameter, degree is another parameter, gamma coefficient, these are inbuilt parameters which SVR holds internally, correct? Now let's scroll down and try to understand what is meant by kernel function. If you scroll down, read this parameters. In kernel, how many kernel SVR provide us, guys? Linear, poly, RBF, sigmoid, pre-computed. So this is SVR or SVM, by default, it provide RBF, and overall we provide 5 kernel function. Understand you? Just go here and let me write down SVR kernels. The first one we have sigmoid, second one RBF, the third one, Venu, just wait, man. Then we have RBF, pre-computed, what else? Sigmoid, polykernel, and then just one second, linear. Yep. So we have polykernel and linear. Understand, you might, whenever multiple choice questions you encounter, the question should be how many kernels follow in SVR. Always understand 1, 2, 3, 4, 5. So we have 5 kernels, and RBF would take by default kernel. RBF will take by default kernel. Understand him up to this? So today we start the session, and while we start the session, we discuss what is SVR, what is equation of SVR, what is hyperplane, what is maximum margin distance. Are you understand what is positive distance, what is meant by negative distance, and how minus a is less than ywx plus b is less than positive a. The math part we finish, then maximum margin plane we discuss in SVM, and then we work on a practical. For the practical, whatever the data set we used yesterday, we fit this model on the same data set. We fit this model on same data sets, and we compare polynomial regression accuracy versus SVR accuracy. That's what we're going to do. Getting my point, team? So just refer to that. And here, okay, let me minimize. So just try this now. First parameters, kernel RBF. If you read this, what is meant by kernel? It specifies the kernel type to be used in algorithm. In SVR algorithms, which kernel used? If none is given, if you does not assign anything, by default system takes RBF. RBF is parameter tuning or hyperparameter tuning? Parameter tuning. If we change to poly, then that means we do a hyperparameter tuning. Pretty clear? Now the next one, degree. By default is what? 3. By default is what? 3. If I didn't explain poly, then this parameters you can't understand, guys. So 3 means degree of the polynomial kernel function. So gamma means scale and auto. What is meant by gamma? Gamma provides 2 parameters, scale and auto. But system by default considered scale. What is meant by scale? Kernel coefficient for RBF, poly, and sigmoid. Let me tell you, y equal to 3x1. 3 is the coefficient of x1 plus 5x2. 5 is coefficient of x2. The same way, the gamma value is the coefficient of linear kernel, polykernel, RBF kernel, like that. Do you understand? Read this one, what exactly it's saying. Kernel coefficient for RBF, poly, sigmoid. RBF is linear or not, kernel or not? So this gamma value is the coefficient of these kernel. And internally, you no need to sit and apply what exactly going on. You not be a researcher. Always understand a difference of researchers and developers. What is developers? Developer the code and implement in real time, and customers use the code. Are you guys understand? What is researcher? Researcher work, they never develop any code, they only research and dig it down. So getting my point, guys? So here, this all internally, all the math functions works. We don't need to go ahead anything. Now let's go to the variable explorer, and I'll go ahead and restart my kernel. And once I restart the kernel, first SVR. SVR means by default which kernel considered, guys? RBF. What is the degree? 3 degree. Okay. Now 3 degrees. So better I can create this one now. Let's have, first we try to build a separate model, then we go to this one. Just NumPy pandas matplotlib, and we split the data to, okay, I think just one moment, copy and just paste here. Just go ahead and execute. Okay. All right. Then PD and this one. Okay. We divide into X and Y. Now the first one I remove. Let's directly go ahead with parameter tuning, and I fit my model. Very 3 lines of code or not? When I fit the model, so here we build a SVR model, regressions model, SVR model. Now what I try to do, can we predict what is the predictions of 6.5 level now? See, this is regression for SVR model, isn't it? Now what I'm trying to do, why pred SVR when you check this? So can you tell me what is model predicted? 130. Are you able to see that? What is the model predictions, guys? 130. Can you do it? Can you do it? Now, is it accurate predictions for 6.5 level? Yesterday we discussed what would be the expected salary, guys? It should between 150 to 200 or not? It should between 150 to 200. But the model predicted is how much? 130. Can you try this? Can you try this? Or maybe in the code, you create a space and now you just create one line, guys. Just go here and I'll mention this now. Or if you confuse, then create a separate note file. This is for this 4 lines is referring to SVR model. Are you guys working offline team? So yesterday, please open the file and it's your wish. You want to add the 4 line or create a new py file and numpy pandas matplotlib, split the data again and do it and predict the model. Now my question, let me know how much score you got. 130 score you got, guys, isn't it? Check that. I mean to say 130, is this accurate? Yes or no? No, it's not an accuracy. So what do you do? What we do if not? Can we go for hyperparameter tuning? But please complete and update me then. Let me know once you complete. Let me know once you complete. You can write a separate, I would say, you can write a separate py file so that you not be confused. Can you create a separate py file? Very simple. Go to file, new file, and again, you don't need to write the offline team. I'm just waiting for you. Once you're done, Sri, can you do one thing? Online team, the one who completed, can you do hyperparameter tune? I mean to say, as we know, we got 130 over here and 130 is not. How do you do apply hyperparameter? Can you change the kernel to different kernel and do the hyperparameter tuning? Can you change the kernels here? How to change the kernel? I can mention kernel equals to, okay, now I'll go ahead and tab kernel equals to how many kernels I have. I think let's try sigmoid. I'll apply sigmoid and let's say gamma. What was by default gamma? Scale or auto? Scale. Can I change to auto now? Okay, now let's rebuild the model and just execute the code one more time. And let's see the predictions of SVR. And what is my model predicted now? 129, less than. Again, it's not accurate. Can we change to another? Where do you stuck, guys? Sorry. This one, I have run the code. Very good, Srikant. So team, are you understand or you understand, right? In SVR, if I got 175, if I compare two model, which is best? SVR model. So we try here to get a good accuracy. Let's do that. What's in there? It's working. So everyone, I want you to finish this and let me know which kernel is best fit kernel for this algorithm. Are you working, buddy? You absent 2 days? That's why you not understand. Say, if you check the data set, can you little, is that possible to reduce? Should try that. So what I'm going to do, I'll try with poly and gamma value to scale and the degree to 4, and then let's build again. And now let's see what is the prediction. I think, oh, I think 134. It's again a less. I think if I remove this degree equals to 5 and try this. Okay, 164. Yes, guys, how much we getting? 164. So 170. So multiple people got, okay, Ratan, you got poly, I got 197. But don't you think 170 is too, no company is offer that much of salary if you compare to the data. 197 means it's almost like AVP level. So the experience that has 164. Yeah, for me also 164. Can you try, sir, regressions.fit sigmoid Anand sigmoid auto? Okay, sigmoid degree 5 129. No, it's not. So my question, every time you change the parameters, the values got shuffled or not, isn't it? So who will decide? It will decided by your organization's people, guys. It will decided by your business leaders, managers. So once you build the model, you have a discussions with the team. So what we do, we'll do a future forecast for this. What is meant by we build the data on historical data or not? We pass the historical data and we build the model. And once we best fit model, if everyone is okay to the model, then we go for a deployment. So now what I want you to do, okay, I want create a detailed report, create a detailed hyper parameter report using all the parameter tuning, guys. Okay, understand? So detailed report means multiple people got multiple responses or not. So please mention like kernel, RBF, and gamma value scale, and let's say how much I got, and I got my model accuracy is 130K, correct? Next one, kernel is sigmoid or maybe poly, and degree equals to 4, and the score is, let's say, 1, I think 64. Same things, poly with degree equals to 5 and score we go to 170. After we build several, okay, scores, now I can show to my manager. I can show to my manager, and manager will finalize which one we picked up. Understand, team? So here, let's assume the polynomial. So we have a one data set. Okay. The data set, we build polynomial model. the model scores 174 point, I think 68 or 78, something like that. Now, SVR model, we got score, how much guys? Let's assume 164.65. Out of the two model we implement on same data, which is the good model out of two model? Polynomial. Same, we will build KNN model as well and we'll check the score. Then we will build decision tree regressions model as well. We'll generate some score by model or not. And then we build RFR model and we generate some score. And we'll finalize which is the best model for this data set. That one will go for deployment. That one we will go for deployment. Team, are you understand? Guys, are you getting my point? So any data sets we can fit multiple model, and whatever the model has good score, then we go for a deployment. So today's session, we built polynomial model we completed, SVR model we completed. So Animesh, a sigmoid 129. Okay, can you please prepare a detailed report, guys? I mean, whatever you mentioned, Animesh, you take Excel sheets and you prepare a report and share to me in the classroom. Are you guys understand or not? Sure, online team, everyone? Can you do it? So rather than you can post, so you open an Excel sheets, you hit and try and get some. Can we build another model now today? So this is very simple. Can we go for another algorithms? Which one those? K nearest neighbor. Okay. So offline team, are you guys understand or not? So anyone get this score? Do you able to try to tune it? Okay, can we go to KNN model or Python? Can we go for KNN or Python function? Let me finish. Okay, Srikant said Python, KNN. KNN. Bhupinder said KNN. What about rest of them? We'll finish KNN today. We'll finish KNN today. Okay. Python will take one day entire. KNN. Okay. Guys, all these algorithms, I'll give you example. The example which you give, the moment when you listen, might be it sounds funny. Maybe you laugh. But the meaning you understand. See, many of the people study in different. I told you the maximum margin hyperplane. Okay, today I introduce a concept called maximum margin hyperplane. What is meant by maximum margin hyperplane? When the distance is maximum, why we consider the maximum margin hyperplane? The error will adjust or not? So how you guys understand error will adjust? So in national highway, do you see many people are go the wrong route or not? For some time it is error, but after it, this error are adjusted or not? Getting my point? For some time it is an error, but after that the errors are adjusted. If the marginal distance is not maximum, you can't do that. So that's the reason the maximum marginal distance is important core concepts of SVM. Remember this one. Now, very simple. In entire ML journey, the K has many places we use K. Many places. So what is meant by K? Let's talk about. I'll try to a simple example and math I'll explain to you later. Okay. Now KNN means K nearest neighbor. See, such a beautiful algorithms and many people. Okay. And what are the math behind KNN? How outliers impact on KNN? What is meant by balanced, imbalanced model? We discuss all those things later. But as I told you, see guys, there is a 3 data points I want to give you. First one, A. Okay, I'm not right here. Okay, just go and try this now. Listen to me. SVR, I hope you guys are clear. And if any questions, please ask again. I will explain you. All these model I repeat many more time in future classes. So just let me close this and wait. Okay, let's see. There is a data point A. A is watch the cricket match. Okay, so India versus Australia. All right, guys. So this due to power failure, I mean this A data point is unable to watch. So A neighbor is B and A neighbor is C and C neighbor is D. These are the neighbors or not? You understand? Very simple example. So now when he is not able to watch, can you tell me based on this example, what is K value? What is K value here? Online team, any guesses? Venu say 3. What about rest of them? 3. Can I say 3? Because 3 neighbors. K value is 3. So when this guy watch, what do you do? He'll ask to the neighbor or not? He'll ask, hey buddy, can you please tell me, do you have a power in your house? He said, yes. Maybe he used generator. And he'll ask to this guy said no. Okay. This guy also said no. Can you please tell me out of 3 decision, which decision is more? Can I say 2 no is greater than 1 yes? So you take a decision based on neighbor's decision is called K nearest neighbor algorithm. Are we clear? You take a decisions based on nearest neighbor is called KNN. So in practically, how exactly it works? If I refer to the team, online team, I hope understand. So in this case, let's consider A is a 1 data point, B is 1 data point, C is 1 data point, D is data point. Can we find out the distance metrics of each and every data points or not, guys? Okay, can we find out the distance metrics of each and every data point? So whatever the distance metrics is minimum, that's what we can conclude. I will explain later because this just an introductions of KNN. So in the KNN, I will go ahead and let's try to understand. Always remember K nearest neighbor, nearest neighbor. In KNN algo, we will use distance metrics. We have 2 type of distance metrics. The first one is Euclidean distance. The second one is Manhattan distance. Okay, so try to understand. I have a data points. So distance between 2 data points, how do you compute? X2 minus X1 whole square plus Y2 minus Y1 whole square root of. It's a Euclidean distance. And if I apply this to find out the distance of 2 points, I can compute the distance of this line. I can say, if I try to find out distance of AC, can I say, man, okay, just Control G. Can I say AC equal to AB plus BC? Can I do this? AC equals to AB plus BC. What I'm trying to say here, all right, just go here and, okay, I'm try this. So I have 2 data points. This is AC. What are the coordinates? X1, Y1, X2, Y2. Understand? So this is Euclidean distance, ED. ED means what? Euclidean distance. x2 minus x1 whole square, y2. Sorry guys, the mouse changed, so because of that the points are a little bit here and there. So this is AC, and if I B now, AC equal to AB plus BC. Which is shortest distance, Euclidean or Manhattan? Which is shortest distance? Anyone? AC is shortest distance or AC equal to AB plus BC? Euclidean distance shortest distance or not? Guys, how come you say Manhattan, guys? Very simple, man. I have a 2 data point. Very straightforward. If I compute a distance, it is the shortest distance. What is farthest distance? The farthest means you can compute like this. You have to compute this and compute this, then sum up. So in KNN algorithms, we use ED and MD. Okay, Euclidean and Manhattan. Now let's go ahead in the same code, the code which you done, no need to write another code. I just try here from sklearn.neighbors. Okay, from sklearn.neighbors, import k-neighbor regression. We have k-neighbor classifier as well. We have k-neighbor regressor, k-neighbor classifier. Now, in this k-neighbor regressor, just go here and control I. What is by default neighbors, guys? What is by default neighbors? So online team, are you understand, or we can discuss tomorrow, or we finished it? What do you want? Can we close today? The first thing, SVR. What I want, we understand the math for SVR, and then we understand math for SVR, and then we build a practical, and we change hyperparameter tuning, and we change hyperparameter tuning, all right, for all the models, I mean for SVR model, and I give a small task to prepare a hyperparameter table, okay, with score. You done this, guys. So this week I'll planning to complete regressions, and I will give one resume projects, guys. Please work. I'll give one resume project.